I have the pleasure to introduce Leon Levy down here and Lucas from VMware. They will, together with me, present on our storage integrations for Site Recovery Manager. And I have to show you this disclaimer slide, and then we'll get started. So basically what we're covering in our presentation today is some of the options that we have for making virtual machines highly available and disaster-proof. We will talk about a little bit what is new in Site Recovery Manager 5.0, some of the things that Lucas will cover, and we'll give you an in-depth overview of how our storage adapter for the EVA works with the new Site Recovery Manager features. And that will be done by Leon. So Leon and I are actually working at Hewlett Packard, and we are there to integrate our storage systems and our software with VMware and with vCenter to basically allow you to invest more time in actually managing the systems instead of maintaining them. And so you can innovate more and look less at your infrastructure. One of the building blocks that we are using in this environment is our cloud system, which is basically a combination of our blade systems and our networking as well as our storage systems. There will be much more announcements this week around what we innovate with together with VMware and HP. You have several options to make your virtual machines highly available and replicate your data across sites. One of them is using host-based replication. Another one is doing storage-based replication, either synchronous or asynchronously. And we support those with the current Site Recovery Manager as well as with the new one. Another option is to actually do clustering of virtual machines looking like this. And we have software from HP that basically manages the replication relationships of the storage systems and allow you to actually fail over virtual machines between sites. This is done through our cluster extension product for the XP P9000 storage system, the P6000 EVA storage systems, as well as our HP3 Port storage systems. Another unique alternative is our P4000 multi-site SAN solution, where we are actually creating a what we call network rate software solution, where we take a storage system and stretch this across sites. And with that solution, we can actually live migrate virtual machines across sites over distance, as well as fail over virtual machines in case your data center fails. Those are just some of the solutions that we have from HP, besides our Site Recovery Manager integrations and our storage replication adapters. And with that, I would like to turn it over to Lucas, and Lucas will give you some overview of what the new features are in Site Recovery Manager.
Great.
Thank you.
Thank you, Matthias. Can you hear me in the back there? All right. So I'm just going to take a quick few minutes to introduce Site Recovery Manager. But first, I'd like to take the opportunity to thank HP that have been working with us for many years, continued success in partnering with us. Site Recovery Manager is one of the most successful vStorage API that we have as an umbrella of vStorage API. One of the first was Site Recovery Manager. Other vStorage API we have is in the area of multi-pathing, pluggable storage architecture. Another one is vStorage API for array integration, which HP have been working very closely with VMware. There's a session that we will have a joint session with HP, so I invite you to go to that session as well. So Site Recovery Manager, a show of hands, how many of you are using Site Recovery Manager today, right? It's a good show of hands. Site Recovery Manager, in simplicity, is really a vCenter plugin, very simple to use. Site Recovery Manager, or SRM, automates the disaster protection and plan migrations for all applications. So essentially, it does three things. One essential is that it provides the replication for applications across to your failover sites for all applications. So beginning with SRM 5, we added for the first time in the industry a hypervisor-based replication. So host-based replication is something that we released and spoke about last VMworld. Today is a reality. So host-based replication, in the feature you'll see as a vSphere replication, and that is, like I mentioned, is the first hypervisor-based replication, and is a cost-efficient because your virtual machines now can be replicated across multiple sites, right, regardless of which storage it lives on. And you can choose to replicate the entire or subsets of the VMDKs of the VM across multiple sites. You get to choose the destination, right? And it works in conjunction with storage array replication. The second essential thing that Site Recovery Manager does is it replaces the traditional manual runbooks, which are error-prone. So imagine the challenges that you have changes in your personnel. You have to keep up to date of those manual runbooks. So Site Recovery Manager replaces the manual runbooks with a centralized protection plan, right? So with a centralized protection plan, you can reduce the amount of time you plan for a disaster from weeks to a matter of minutes. So significantly save your operating expense or OPEX, right? The third essential thing that Site Recovery Manager does is it automates your failover. So it provides you a guarantee, a success repeatable failover mechanism. So you can failover, you can test failover non-disruptively at any time to look into your recovery time objective, to look for errors in the configuration in the setup. And most importantly, actually one of the key features that we roll out for SRM 5 is automation of failback. So now you can reprotect, basically bidirectional failover. Okay, so this is a quick snapshot of what will be the changes for SRM 5. I invite you to visit Ken's other two sessions. These are each 1 hour long, deep dive into what's new with SRM 5. But as a quick snapshot, as I mentioned earlier, one of the key changes that we made to SRM 5 is vSphere replication. It comes as a bundle at no additional cost. And as I mentioned, it's a very cost-efficient way to provide replication for your application across multiple sites. Another important feature we added was automated failback or reprotect. And of course, we have plan migration, a new workflow engine, and other granular control over the VM startup order, for example. We can now choose to start up the virtual machine. For example, your master database VM needs to power up first, followed by your database, followed by your Exchange, or your app, VApp, and then your Apache server, for example. Other changes we made is to open up APIs for the SRM and also include IPv6 support. Okay. So if you're familiar with SRM 4, not much has changed other than the addition of a few components, and I point out here. Of course, for SRM to work, you have a replicated environment, a mirror environment. Of course, when you install SRM, you start out with the database. It could be a SQL or Oracle server, and then you install the SRM server. And of course, as I mentioned, in simplicity, SRM is a vCenter plugin. So you install the SRM plugin on both sides. And what's new now is you have the replication management server. And notice for SRM 5, each ESX server now has a replication agent that's native to ESX. And last but not least, you check with HP to install the storage replication adapter. And with that, quick introduction, I'd like to now turn over to Leon to take you through the installation, the best practices of stored replication adapter.
All right. Can you hear me okay? Okay. So thank you, Lucas, and thank you, Matthias. My name's Leon Levy. I'm a software design engineer at HP in our storage lab. We work on solutions that integrate our storage with DR solutions such as Site Recovery Manager. Coming up, along with the release of Site Recovery Manager 5.0, we're releasing a new adapter for our P6000 EVA family of storage arrays. And our adapter is called HP P6000 EVA Storage Replication Adapter for VMware vCenter SRM 5.0. That's the official name. It's catchy. So in this first section here, I'm going to give you an overview of what is the SRA. From the show of hands I saw earlier, it looks like you guys are familiar with Site Recovery Manager. With our storage system, we have an adapter that sits between the SRM server layer and communicates with this new version of Site Recovery Manager and our new adapter. We're communicating indirectly with array management through this layer called the Storage Admin Portal. And I'm going to go into that in a lot of depth. I'm going to bring it up multiple times in this presentation and explain what it is and what its role is and the solution. But basically, the Storage Admin Portal is bundled with Site Recovery Manager, our Site Recovery Manager adapter, to basically act as a single entry point for communicating with your command view servers in a DR solution where you have multiple command view servers. So what is the SRA? So SRA stands for Site Recovery Adapter. And our adapter for the P6000 EVA storage line of storage will enable our storage replication to work with VMware Site Recovery Manager 5.0. We use array-based replication called continuous access replication for remote replication across sites. We also use, within the solution, we use our local replication software called Business Copy, and I'll show you where both of those play a role in the solution later on. But basically, with continuous access for P6000 EVA arrays, we have consistency groups, which we call DR groups or data replication groups. These contain dereplicated volumes as a replication set that will be used for your VMs, data stores, or raw devices that are replicated from one site to another so that you can fail over or recover your VMs in a recovery situation, whether it be a planned migration or a DR scenario. Like Matthias said, we support both synchronous and asynchronous replication in this solution. VMware Site Recovery Manager calls our adapter to perform these following workflows. I'm going to go into those in a lot more detail later on too. Basically, it's used to discover local and peer arrays. So it's going to go through a list and discover which arrays are being managed, along with automating discovery of peer information. So automatically discovering which arrays an array in a particular site is replicating to. It's going to be used to now, with SRM 5.0, they support consistency group discovery. So now we can utilize DR group information within the P6000 EVA continuous access environment and get the devices contained within those DR groups and consistency groups, and also discover what state those devices are in, whether they're in a source or target mode. And based on this information, Site Recovery Manager will be able to automatically figure out which direction your volumes are being replicated. It's also used to ensure that your DR groups or consistency groups are synchronized across data centers prior to failing them over to the remote site. Then for recovery, failing over the DR group, which is a dynamic swap of replication between your source and target array so that you can bring up your VMs and their disk resources up at the recovery site. And then also it's utilized for the test recovery plan operation where you can perform non-disruptive testing at your recovery site utilizing our local replication business copy software to create allocate on-demand snapshots that are basically snapshots of your replicated devices so you can ensure that you have enough resources to run your protected VMs in a real disaster scenario. So these next few slides just kind of show where we support, what models of EVAs and other arrays that we're going to support with Site Recovery Manager 5.0. So currently, as SRM 5.0 is released, we'll be supporting our entire line of P6000 and EVA arrays that we support within connectivity. We'll be supporting Command View, which is our array management software version 9.3 and 9.0. I mentioned earlier we'll be supporting synchronous and asynchronous replication. Further down the road, we're going to be supporting all our families of arrays, including, this should say, P9000 series of and XP series of arrays. This just kind of lists some of the support information and replication types that we'll be supporting with that when that is released. We also we'll be supporting in the future HP3 Port 3-par replication in this type of environment as well, and left hand. And further down the road are P2000 MSA arrays, and that's down the road though. So now I'm going to get into the architecture of this type of environment. I'm going to get in pretty deep. I'll talk about basically some of the things you need to keep in mind when you're setting up this type of environment. So you saw this kind of layered diagram in a previous slide where we show where the SRA is basically between storage array management and SRM. This slide here just illustrates that you're basically configuring that type of layer type of configuration in both sites for high availability and DR purposes. So when one site goes down, the other layer can take over. All operations are done indirectly through Command View, which is our array management software, and through this layer called the Storage Admin Portal. So let me go into this. So Storage Administration Portal is actually a utility and a necessary configuration tool that we actually bundle with, that we will be bundling with our SRA for SRM 5.0 for the EVA and P6000 storage arrays. And basically what it's used to do is allow for SRA to basically log into that and perform any of the array and disk and replication operations through a single entry point. And basically, Storage Administration Portal is used to manage what Command View servers are in your environment and what storage arrays are in your environment. So as you can see here, this is just showing one site. In Site A, we have your Storage Administration Portal set up to manage Command View servers both from Site A and Site B, where we have array management servers managing both storage systems in this environment. And just to illustrate, this would be set up identically in your remote data center. So I'll show you how that looks later on. So now I'm going to talk about some of the installation and configuration practices to follow when you're setting up this environment. Some of them I'll focus on in a little bit more depth. Others I'll go over quickly. If there's time and there's questions about them later on, I can answer when I'm done presenting here. So basically, I'm going to go over some of the things to keep in mind when configuring your SAN and what you need to do prior to installing your SRA. Talk about the simplicity of installing the SRA and some of the post-installation steps that are required with P6000 storage with this Storage Administration Portal, which I've mentioned. So this is a pretty standard DR zoning configuration for P6000 EVAs. Basically, what you have here is you have local zoning and you have remote zonings or ISL zonings. So in the blue circles here, we see the local ESX hosts in your data center A are only zoned to see the array in data center A. The ESX server in data center B is zoned to see the array in data center B. Then we have array management, so our Command View servers, basically they are zoned with both arrays since they can manage both arrays actively or passively at any given time. And having the arrays together allows the arrays to communicate with one another for remote replication. So this next slide is just kind of a logical diagram that shows how this zoning makes your environment look like. So basically you see your connection from the ESX servers to their local arrays. You see a connection between the two arrays for replication, and you see Command View's connection to your storage systems, local and remote. As I mentioned before, we use continuous access replication and business copy replication in this environment. So it's required that you install licenses for both of these types of replication software on your arrays. I'm going to go over these quickly, but basically you'll need to set up your disk environment. These disks will be used be created at your primary storage system initially. And once you place them into replication groups, all the information within them will be replicated to your remote site. So here, the slide just talks about putting them into our data replication DR groups, which are our consistency groups, and basically the primary way you manage replication on the P6000 and EVA storage arrays. So once you put them in there, you can fail over the replication direction and the read-write access attributes of your volumes once they're in these DR groups. And then presentation, this is actually a pretty important slide here. So with failover recovery, we don't present them at runtime during the recovery. So it's really important that you present the volumes from your local side, your protected side, to the protected ESX servers. And at the target site, you want to present the read-only target LUNs that are in your replication group to the ESX servers that will be used for your recovery ESX servers. So this needs to be done ahead of time as part of your setup. Once you get this far and SRM is installed at both of your sites, you can install our adapter software. So it's a pretty straightforward wizard that we have to install it. We do run our adapter as a web service, so there's some parts of the installation where it gives you a list of default ports that it's going to be using, and you can change those. I don't have screenshots of that, but I'll just explain it here. I talked about that storage administration portal, so that actually you need to authenticate to get into it. So during this installation step, you'll set the initial password to get into the storage administration portal. You can change it at a later time. We have utilities that we install along with our adapter to change that if needed. Once you've installed the adapter, you can use Site Recovery Manager. One of the nice new features of SRM 5.0 is that when you install a new adapter, you don't need to restart the service. You can simply hit a rescan button and it'll automatically detect newly installed SRAs. And as it mentions here in the second bullet, you need to install identically and rescan at both sites. So this slide here shows what the interface for the storage administration portal looks like when it's configured at a particular site. So this would look identical on both sites. So like I mentioned before, this utility or management utility is installed with our adapter, and you launch it. It's a web application that runs within your browser. It's launched from the Windows Start menu. Once you authenticate in with the password that you set during installation, you configure which command view array managers you're using in your environment. So as you can see here, we have our command view server in data center A as well as data center B configured in the storage admin portal. We also have our arrays. So we have two arrays, Hurricane A and Hurricane B. Hurricane A resides in data center A, and Hurricane B resides in data center B. So as you can see, the entire storage environment is configured at each site through the storage administration portal. And our adapter will basically know which arrays to look for when it's being called by Site Recovery Manager once this is set up. So this is just showing a potential configuration for Site Recovery Manager. So typically we talk about two sites going from site A to site B. This one shows kind of a 1 to 2 potential configuration that you could do with Site Recovery Manager and our P6000 EVA replication. Just note that in this shared recovery data center, we have two instances of Site Recovery Manager. So basically you have two independent SRA environments running and configured between 3 different arrays. So earlier I talked about what the SRA is and what its role serves in a Site Recovery Manager environment. So now I'm going to kind of go into more depth to show you what happens during some end-to-end workflows of Site Recovery Manager on the array level on the P6000 EVA, just so you understand what exactly is going on the array for troubleshooting and understanding some of these best practices. So this is the list of Site Recovery Manager workflows that our adapter follows and conforms to. So basically our adapter is called during the following workflows, which is creating the array manager, basically the initial configuration of your array manager, enabling the discovered replication array pair that you want to use in your SRM environment. So once all managed arrays are discovered, and a user will enable which pair of arrays they want to use. Our adapter is called once again to discover replicated devices and the states that they're in, and a bunch of information about those devices. Our adapter is then called for testing a recovery plan and cleanup. So I'll show you what happens on the array when those operations are called. Plan migration from A to B. So in Site Recovery Manager now in 5.0, they have this notion of recovering your VMs for a disaster DR scenario or a planned migration where you were to move your VMs from one site to another without any sort of disaster scenario. And then I'm going to talk about what the adapter does during that. Reprotect, which Lucas was mentioning earlier, is basically the mechanism within Site Recovery Manager to set up your protection groups and recovery plans to automatically fail back to your prior state, to like a pre-failover state. And then we'll talk about disaster recovery when you lose an entire site, and then what some of the post-disaster operations that occur once your primary site is restored. So once you installed your adapter and Site Recovery Manager detects it, you configure it to communicate with your storage administrator portal. So once you do this and you click next and it goes off, it basically goes and discovers all the managed arrays that you've configured in that storage administration portal. So as this slide shows here, it'll go hit the first array, so the array that's managed in Data Center A. It'll discover information about that array, such as host port, worldwide names, firmware versions, etc. But it'll also automatically detect at this point the arrays which it's replicating to. And it gets this information based on which arrays it has DR groups set up between. So in a data replication group where you have your replicated disks, as long as you have those configured, it'll be able to detect that there's a replication relationship between your local and another array. If you just have a physical replication link set up between them, but you haven't set up any DR groups at this point, it won't detect these as peers. So that's why this slide just mentions that you actually need to have a DR group configured in this environment before it'll discover local and peer array information. Once you enable an array pair, the adapter is called again to discover the replicated consistency groups and devices and the states of those consistency sets and devices between an array pair. So once you've figured out which storage system you want to use, so in this instance we have storage A with peer array storage B, the adapter will be called by Site Recovery Manager again on storage system A to discover all the replicated devices on it. So here we have replication going from A to B, and we have another replication group going from B to A. And now Site Recovery Manager and the adapter is smart enough to figure out which direction is being replicated based on the read-write information of the devices, and the DR group actually will return status to SRM, whether it's a source or target mode at this particular array, and then it'll go ahead and discover that, go to the other array that is the peer array, and basically discover all replicated devices on that system and pair them up based on disk ID information that our adapter returns, so that it can set up replicated data store groups for protection groups later on. So this slide here just shows what type of information it gets. So like I said before, it automatically detects whether a consistency group is in source or target mode at a particular array. If it's in source mode, it gets more detailed information about the devices within the consistency group. So consistency group and DR group here are one and the same. So consistency group is more of SRM, what we call DR group. So within the DR group, it's going to get all the device information, including all the source devices, IDs, the target IDs of the devices at the remote array, what ID they're using, getting host presentation information such as which host group the device is presented to and what LUN number is assigned to that particular host and host group. For target arrays, it merely gets the ID of the target device, and it does this. It'll match that up with the corresponding source devices at the other site. So during a test recovery, there's basically 4 key steps that our adapter is called to do. The first thing it does when you go to test a recovery plan, what SRM does now, it calls our adapter to ensure that replication I/O is synchronized between sites. Since continuous access for the P6000 EVA replication, it's using synchronous replication. So if your replication link is healthy and up and running, it should be synchronized already. But in cases that it isn't, it'll first, ensure that your replication I/O, if it was in a suspended state, is resumed, and it'll monitor the progress if there's any pending resynchronization going between site A and B. It'll monitor that progress before it's completed. Once it's completed, it'll go on to the next step. The next step in this recovery plan is basically creating snapshots of your target devices at data center B. So basically, they are snapshots of your replicated VMs at the replicated site, and the adapter is then called to present those snapshots to your recovery ESX servers so that the VMs can run at this recovery site in this test bubble without disrupting your protected VMs running in a production environment. And basically, this is done to allow that your configuration is correct, also to ensure that your ESX servers at your recovery site have enough resources to run those protected VMs, and you can figure out if part of the recovery plan you can specify any non-critical VMs that need to shut down in order to free up resources for your VMs. So once we have done this and the test operation is complete, there's a cleanup phase, and our adapter is then simply called, once the test VMs have been shut down, our adapter is then called just to clean up the snapshot environment. So it's a pretty straightforward operation. So now I'm going to talk about plan migration from one site to another. So that's basically running the recovery plan in a healthy environment. If you are in a planned manner when you want to move your replicated VMs from one site to another. So this is different than vMotion. There is downtime. It shuts down the VM, swaps the replication direction, and brings it up at the other site. So just like in the test recovery scenario, the adapter is called. It's the same piece of code that ensures that the replication I/O is still up and running and monitors the progress until it's completed. At this point, once that's done, Site Recovery Manager will shut down the protected VMs running in the protected site. And our adapter is then called by Site Recovery Manager to create these snapshots of the source devices. And this is one of the operations that we put in here to conform to SRM's specification. It was later we found out that these snapshots aren't going to be currently supported in the initial release of Site Recovery Manager 5.0, but we were required to do this operation anyway. But just to note that these snapshots are experimental and not supported, and they're temporary. So I just mentioned this here because if you see these snapshots pop up in your environment, just know that we intended to do that, and our adapter will clean it up later on. At this point, when the VMs have shut down, SRM calls our adapter again to ensure that replication I/O is still resumed and synchronized between sites. That could be due to any pending asynchronous writes that need to be replicated between sites. And then at this point, it'll recover storage by reversing the replication direction. So previously we had it set up this way, and the adapter is called to do a failover on your replication pair. So now replication is going the other direction, and your read-write relationship between the replication group has been reversed. And this is just a note saying, I mentioned this earlier as part of the some of the configuration steps that you need to present. These volumes at the target site are intended to be presented ahead of time before you ever run a recovery plan in this type of scenario. So now we're going to talk about reprotect. So reprotect is the site recovery manager operation after you've recovered your VMs. It ensures that it sets up replication for other adapters, and our adapter calls our adapter to ensure that we can fail back. So since we do a dynamic swap of our replication group, so our replication pair, it's an instantaneous replication reversal and read-write relationship swap. Basically, our adapter is called to ensure that the source target or source destination relationship is still valid, and it'll return any errors if it isn't. And if replication IO has been suspended, it'll go ahead and resume replication. Once that is complete, then you can you can run a recovery plan again and fail back without any further configuration steps. So like I said, failback is now automated within Site Recovery Manager. This slide just basically shows the same steps, 1 through 5, are the exact same steps that we followed for running a recovery plan, but basically it's just performing all the same operations in the reverse direction. So in previous versions of Site Recovery Manager, this was a manual step, and so you actually needed to go in and change your vCenter environment and unmanaged systems, and recreate protection groups, recreate recovery plans. Now you just create one protection group, one recovery plan, and you can automatically fail over and fail back your VMs. And that temporary snapshot I mentioned earlier, during this fail back, it'll be deleted. For disaster recovery, basically it's the same as running a recovery plan and a plan migration without checking the replication status beforehand or doing any of the operations that are done prior to replication failover. So I'll just talk about that here. So if you were to lose your site, you're replicating from A to B, the adapter is simply called to logically reverse the replication. You've lost your site A, but basically in your recovery site, your disks are now in read-write mode. And once your data center is recovered, if it's easily recovered, it basically resumes replication from B to A. So in P6000 EVAs, there's a setting in your DR group for your DR group called suspend on links down, and you can actually set up whether or not you want it to automatically resume replication once your original protected site comes back up, or to keep replication IO suspended in the case that you want to do any sort of manual intervention before you bring up sites. And that's basically all I have for the end-to-end workflows. So I think I have time for questions, but first I'm going to have Matthias come up here. And
thanks, Leon. I just wanted to let you know that we have some super session coming up tomorrow at 11:30, where we talk about our conversion infrastructure and how that relates to VMware implementations. We'll talk to our cloud systems and how they relate to VMware implementations on I think Tuesday and Thursday. And we have a Boubacar together on stage with Lucas tomorrow to talk about our vStorage API integrations with all of our storage system. That will be a very in-depth session, and I invite you to that as well. And then we have our network guys talking about how you can configure our ProCurve network environment and our Flex Fabric environments in the VMware configurations. So thanks, Leon.
Right.
And if you have any questions, feel free to ask us.
All right. Thank you very much. Yeah. Yeah.